Last time we took an extended look at the orbital notation, and I told you how much I liked it, or I prefer it, because it does show us all four quantum numbers for each electron. It's very helpful, but as you saw firsthand from the last lesson, it is a bit of a beatdown to write those things out, especially as we get into the larger elements when the D's are involved, and can you even imagine writing out the F's like that? So sort of as a trade-off, people have begun to use the electron configuration, and it works perfectly fine for most applications. Instead of arrows in electron configuration, we're going to use superscript numbers. And we're only going to represent two of the four quantum numbers. We're only going to worry about the N, which is the principal quantum number, and then the L, which shows us the subshell. So in other words, level and sublevel are the only two pieces of information we're showing. And then the third piece of information are the subscripts. What these numbers tell you are how many electrons are in these subshells that are being designated with the two quantum numbers. Long story short, we're making a shortcut for those extremely long orbital notations that we did. You still need a periodic table, and you still need your off-ball diagram if you haven't got either of them memorized yet. So once you hit pause and grab those two things if you need to. Okay, now that you got your stuff, we're going to do the same ones we did last time, at least through magnesium, so you can at least compare that work. For hydrogen, we have one electron, so that is a 1s. That is not an orbital, it's technically the subshell this time, even though they are exactly the same. And we just have one electron. For helium, the same subshell, but there are two electrons. For lithium, I have three electrons, so I complete the first energy level, and then I go to the second energy level where there's a 2s subshell, and I'll put my third and final electron there. For boron has 5 electrons, so that's 1s2, 2s2, and then those two are full, so I go to the third available subshell, which now is at 2p, and we are not going to break these up into x, y, z. The electron configuration takes away that m quantum number. So instead of writing all that out, I'm just going to put how many electrons are in the p. In this case, it's just one. For nitrogen, we have 7, so 1s2, 2s2, and now the 2 p's. Again, we're not breaking these up. Now we know that there are 3 electrons in the 2p subshell for nitrogen. Okay, oxygen has 8, so we have 1s2, 2s2, 2p, just one more, so that's 2p4. A lot faster, isn't it? And then for magnesium, we have 12 electrons, so 1s2, 2s2, 2p, and we're going to fill the 2p up completely. And that'll take us to 10 electrons, which is the same as neon. And I have 2 more left over, and they will fit nicely into the 3s subshell / orbital. Now you'll really like this orbital notation as we get into the transition metals. And we can even take this beyond transition. I'm not scared of anything now that I have electron configuration at my disposal. Alright, so copper's first. Copper has 29 electrons. So we're going to start out 1s2, 2s2, 2p6, that's 10, 3s2, 3p6. That takes me to 18, that's argon. Then 4s2, it takes me to 20 electrons, that's calcium. And then the next thing up are those 3 Ds that we're not going to break up now. And I have 9 left over. And 9 will fit in Ds. Ds can hold up to 10. If you ever forget that, just count the number of the columns in the D block of the periodic table. And the same goes for the P block. Alright, so that's as far as we went really with the orbital notation last time. Let's go deep on the periodic table now. Let's go to find bismuth, which is element number 83. So we're going to get carried away now. 83 electrons, starting with 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. All right, let's catch our breath. That's 20 electrons. That puts us at calcium. Find that on your periodic table and go just to the right, and then we'll enter the D block. So that's going to be 3D. And we'll go all the way to the end of the 3Ds, which is 10. So that takes us to element zinc. Just kind of looking ahead here, I see that bismuth is on row 1, 2, 3, 4, 5, row 6 of the periodic table. So I know I don't need to really start slowing down until I get to a 6s probably. And I also know that bismuth is in the P block. So I can probably go full steam ahead here until I get to the P block. And I'm going to use my finger to trace the periodic table. Alright, so put your finger on zinc and go just to the right. We'll enter the P block on the 4th row, so next is 4p6. Okay. After krypton, go to element number 37, that's rubidium. That is 5s. Then we'll enter the D block again at the 4D level, and we'll go all the way across it, so 4D10. Now your fingers should be on element number 49, which is indium, and now we are on the 5p, and go all the way to the end, 6. Your fingers should now be on xenon, which is element 54. Now we are on row 6. So we'll go over 2. That puts us at barium. And then look what happens next. From 56, 57, we jump down to the F block. So we have to now go from 6s to 4f. 4f, 14. The F sublevel can hold 14 electrons. That takes us then back up to element number 72. And we have the 5D10. And that takes me through mercury. And then finally, 6p. I know I'm getting close. Bismuth is the 3rd one over, so 3 in the P. There's the full electron configuration for bismuth. Don't forget that the D orbitals are always 1 row behind the main group, which is S and P, and the Fs are always 2 behind. So you see on the row 6, the F is 2 behind and the D is 1 behind. That's always true. Alright, so now you test yourself, hit pause, and try Rutherfordium, which is element 104, and have all the confidence in the world in the periodic table. Let it tell you what to write. Hit pause and go. Alright, so let's check your work. Rutherfordium has 104. So you would have 1s2. You know what? I'm going to cheat. You can chalk this up probably as being lazy, but guilty as charged. I'm going to start at bismuth, which is where we just were. Bismuth is element 83, and I'm going to go ahead and turn that into a 6, and that takes me to radon, and that's 86 electrons. So I'm going to start row 7 now. Row 7 is going to be 7s2. Then the tricky one here is AC, actinium. Actinium, element 89, is actually a 6d1 element here, but we're going to go past that. So I'm just going to kind of hold off on that one. To get to 104, I have to go completely through the 5F sublevel, all 14 of them. Then I go back to the 6D, and I just want to say, don't forget actinium that we skipped over. There are actually 2 in the 6D. So that is the full electron configuration for Rutherfordium.